Okay, so hello students, welcome back. This is Suyaj Bajpayee, Suyaj Bhaiya here in front of you, and today we are going to solve some numerical based on the concept of uniform accelerated motion. So what do you mean by uniform accelerated motion? When the acceleration is constant. Okay, constant, and in this case we have to use three equations of motion, that is v is equals to u plus at, s equals to ut plus half at square, v square is equals to u square plus 2as. We also know one sign convention. What is sign convention? So sign convention we have like this is positive, clear, this is negative, okay, this is positive, and this is negative over there. Just check everyone, right? I hope this thing is very much clear to all of you. So now just 1 minute everyone. Yeah, okay. So here we will solve this numerical which is based on the same concept. Okay, so let me solve this for you. So we have already covered some basic concept based on that, and we have already solved some of the numericals based on these concepts. Okay, so today in this lecture we'll solve two numericals based on this concept, and then we'll see some of the special cases, okay, of free falling body, and then this concept of uniform accelerated motion will come to an end, and in the next lecture we will start our non-uniformly accelerated motion concept, right? Okay, so let's start. A balloon starting from the ground has been ascending vertically at a uniform velocity for 4 seconds. Okay, so suppose here we have a balloon. Okay, so yeah, like this, suppose this is our balloon. Okay, and yeah, it is ascending with a uniform velocity of some uniform velocity, right? For 4 seconds it is ascending, right? And a stone let fall from it reaches the ground in 6 seconds. Means suppose this balloon is ascending, suppose this is your ground, okay everyone, and this balloon is ascending from the ground, and in 4 seconds it will reach to some height, right? It will reach to some height, and from this balloon a stone have been dropped. Okay, so suppose this balloon reached to this height, right? This height, and at this particular point a stone have been dropped from this balloon, and this stone which will reach reach the ground, okay, in next 6 seconds, right? In 6 seconds. So you have to find the velocity of the balloon and its height when stone was let fall. So students, just pause the video, clear, solve and find the answer, and then see the solution, and mark your learnings, what you have learned from here, mark learnings. Okay, this is the method you all have to follow. When I will solve any of the numerical, this is what you have to do, right? So students, let me tell you here, just let me ask you one thing. I hope you have solved it by yourself. Now let me ask you one thing, that when this stone will be dropped from a moving balloon, what kind of motion this stone will go through, right? So will this stone come directly to here, or will it go upward and then its velocity will become 0, then it will come down? Think. So yeah, because this stone is departing from this balloon, and this balloon has some velocity u, okay, has some velocity, uniform velocity u. So this stone also have the initial velocity to be as u in the upward direction. So this stone will not fall down directly, it will go up, then it will come down, right? Just think about it, right students? Okay. So now let me solve this numerical for you. Okay, so let the velocity of balloon to be u. In 4 seconds this height attained by the balloon is 4 times u. Just think. Okay, because the balloon is moving with uniform velocity, so what is the displacement covered by the balloon is simply 4 into u, time into your velocity, right? So 4u. Okay, so this is the height of the stone. Now the stone have been dropped. Okay, so what is the initial velocity of a stone? Initial velocity of a stone is u. Check. Whatever the velocity of balloon, that will be the velocity of a stone when the stone is departing from this balloon, right? Just check everyone. I hope this thing is very much clear. Means when this stone is departing from this balloon, from moving balloon, then the initial velocity of a stone is same as that of the balloon. That's it, right? Now what we have to do? Okay, so now we have to use our equations of motions. Clear? So what do we know here? We know the initial velocity of balloon, that is u. Okay, and what else we know? We know that this stone will move like this and it will come here. So what is the displacement of the stone? We know, right? So the displacement of the stone is what? This height. Okay, what is that? H. Okay, or you can say 4u, but minus of 4u. Why minus anyone? Because it is in the downward direction. The displacement is in downward direction. This is your initial position, this is your initial position, and this will be your final position. So the displacement here is in downward direction, so that's why it is negative here. Just check everyone, right? Clear? And you have to find the time. Clear? You have to find the velocity of the balloon and its height, right? So yeah, so what else we know here? Yeah, we don't know time. We know here acceleration. What is acceleration? It is minus g. Just check everyone, right? It is minus g over there thing. And yeah, it is given that this stone will reach to the ground in 6 seconds. We also know the time. So which equation should we apply here to find u, right? We have to find u. This u we don't know, right? Velocity of balloon. So which equation we have to apply? First equation of motion, second equation of motion, or third equation of motion? Just check everyone. We know time. Yeah, so you are correct. We have to apply second equation of motion. S equals to ut plus half at square. This is second equation of motion. That is what we have to apply here. So S is equals to minus 4u, and velocity of a stone is plus u, and time is 6, plus half a is minus 10, you can say, and 6 square. Just check everyone. Now you will solve this equation and you will get your u. Okay, just check all of you, everyone. So this is 2u will be equals to what? Half, okay, 10 and 6 square. Check. Is that clear, right? So from here you will get this u to be as what? U to be as 1 by 4 into 10. Yeah, let me give you the answer finally. Yeah, you can also solve it, right? This is 5, and here you will have 5 into 6 into 3 6 are 80 into 5. Yeah, that will be your velocity, right? So let me solve it for you in with permanent case. Okay, so yeah, we know the initial velocity u is equals to plus u, right? And displacement is equals to minus 4u, that is h, nothing but h, right? Then acceleration is equals to minus g. Clear? Or you can say minus 10 meter per second square. All right, for simplicity, time is equals to 6 seconds. Just check all of you. Then s equals to ut plus half at square. Okay, so s is minus 4u, u is u, t is 6, check all of you, plus half, a is minus 10 and 6 square, right? So now, yeah, I have done a mistake earlier when I was solving by this color. Okay, so yeah, it is minus 10u, right, is equals to half, okay, and it is minus 10 6 square. All right, so that will be nothing. This 10 and minus will cancel out, and you will get this u to be as 36 by 2, it is 18 meter per second. I hope this thing is very much clear to all of you. Just check everyone. Is that clear? So this will be your velocity of the balloon. Now velocity we have found. What we have to find? Its height when the stone was left fall. So what is the height? It is simply 4u, means 4 into 18, that is 72 meter. That's all. Okay students, I hope this thing is very much clear to you. If you have any problem, if you have any doubt, you can comment here. I will, or you can go to our Telegram. You will get the solutions, right? I hope this thing is very much clear to all of you. Thank you students. Now let us proceed to one more numerical based on the same concept, and yeah, this is it. So here we have a car. It starts from rest and accelerates uniformly, means acceleration is constant, right, for 10 seconds to a velocity 8 meter per second, right? It then run at a constant velocity and is finally brought to rest in 64 meter. Clear? Means a car starts from rest, accelerates uniformly for 10 seconds, right? Accelerates uniformly for 10 seconds with a velocity of 8 meter per second. It then run at a constant velocity and finally brought to rest in 64 meter with a constant retardation also. The total distance covered by the car is 584 meter. Find the value of acceleration, retardation, and total time taken. Okay student, so just pause this. Okay, pause the video. Clear? Solve find answer, clear, find answer, and then see solution and mark your learnings. Mark learnings. Right, students? This is what you have to do when I solve any question. Okay, so now, so the hint behind this question is you have to draw the VT curve, VT graph you have to draw. Okay, you have to draw the VT graph, velocity time graph. So let me draw this graph for you here. So yes, here we have velocity in the y-axis, and in the x-axis we have time. Clear? So first retardation, this is velocity and this is time. Clear? So first we have acceleration, so velocity is increasing, then the velocity will be constant. Clear? And then we have a retardation. Check everyone. Right? So this kind of a graph we have, and let me divide this graph in some sections. Okay, so a car start from rest. Okay, a car start from rest, accelerate uniformly for 10 seconds. So this time is 10 seconds. Okay, to a velocity of 8 meter per second. Accelerate uniformly to a velocity means this velocity, maximum velocity, have become 8 meter per second. Check everyone, right? If then run at a constant velocity, then this constant velocity continues, right? And finally it brought to rest. Okay, it brought to rest here in 64 meter with a constant retardation. Clear? Means this is given to be as 64 meter. Okay, whatever the distance have been covered here during retardation, right? The total distance covered by the car is 584. So students, you all know that the area under VT graph is displacement, okay, or distance. Clear? We all know that, right? If it is in the upward direction, it is displacement. Clear? So in this case, the direction is not changing, the direction of car is not changing, so distance is equals to displacement here in this case. Displacement is equals to distance here in this case, right? So this total area is 584, it is given, right? You have to find the value of acceleration, retardation, and total time taken. So this time is given to you as what? 10 seconds. 10 seconds. All right. Clear? So, and final velocity is given to be as what? Final velocity is given to be as 8 meter per second. So from here you can find your acceleration. So acceleration is what? So final velocity 8 minus initial velocity, start from rest 0, divided by time taken 10 seconds. So it is 0.8 meter per second square. This is your acceleration, right? No problem. Then yeah, you can also find the total time is given here. The total distance is 584 meter. This is given, and it's finally brought to rest in 64 meter. All right, no problem here, no problem. Okay, yes. So okay, all right. So what do we have to do is we have to take this thing to be x and this thing to be y. This time to be x, this time to be y, or we can say t1 t2. Okay, let me take it to be, yeah, this to be t1 and this to be t2, right? T1 t2 we have to find, then we can get everything. Okay, so what is given here? The distance covered here when the brakes are applied, right? It is given the total distance covered by the car is 584. This is given, and if then run at a constant velocity and is finally brought to rest in 64 meter with a constant retardation. So this retardation distance covered is 64. Okay, just check. So your total distance 584 will be equals to what? Will be equals to what? This is first section, this is second section, this is third section. So the summation of all the area of these sections, right? So first section is area is half, okay, base into height. So base is 10 and height is 8, plus the next section 8, clear, into T1, clear, plus the next section is what? The next section is half, clear. The next section is 64 given here, 64 simply, right? This area is given 64. So from here you will get your T1. Check everyone, right? And from this 64 is equals to what? Half base into height. Okay, again half base into height. Check this area. This area is the distance covered during retardation, right? So 64 is equal to half base is T2, clear? T2 into height is what? 8, that's it, right? So your T2 is equals to, from here, just check everyone, this T2 will be equals to, this is cutting 8 and 16, right? So 16 second is your T2. What about T1? So for T1 we will solve it here. 584. Okay, let me do it from by permanent marker. Okay, this is half base 10 into height 8 plus half, sorry, not half, this second section is a rectangle, right? So what is that? So T1, 8 into T1, 8 into T1 plus simply 64, this area, right? So from here what do we have? This is 4 and this is 520 is equals to, right, 520 minus what? It is 40. Okay, this will be equals to 8T1. Check, 480 by 8 is equals to T1. Clear? So from here what do we have? This will be equals to, T1 will be equals to, yeah, you can simply say this to be as 60. Okay, just check all of you. So yeah, this is 60 seconds. Okay, so the total time is simply from here, what is the total time? Yeah, it is 10 plus 60 plus 16. All right, over here, just check all of you. Clear? And what is the value of acceleration? We have found, you can find the value of retardation also if you will get this T1, right? So final velocity 0 minus initial velocity 8 divided by the time taken T2. T2 is what? 16, that's it. So 0.5. So retardation is minus 0.5. So retardation is minus 0.5 meter per second square. Okay, I hope this thing is very much clear to you. Okay, so this is the solution given over there, here. Okay, yeah, so the answers are correct. I hope this is fine. If you don't okay with the solution, if you have any problem, you can go with the solution as well. You can get this PDF PPT clear in our Telegram group, so just join our Telegram group also. Now let us discuss some of the basic cases that we have to do here before proceeding. Okay, so one case based on the concept of freely falling body. Okay student, you don't have to learn any of the formula here, clear? Let me go with some cases. So here's the first case. You don't have to learn anything, right, students? First thing is this, note it down. So when we throw a ball with a velocity u, it will reach to a maximum height. Can anyone tell what is the maximum height? Yeah, but you don't have to learn it, right? So what we'll do, this is our initial position, this is our final position. Okay, what we know, we have to find the maximum height h max. Clear? So at maximum height, velocity will be 0. Acceleration here is minus g, right? Velocity, initial velocity is u given, right? So we have to find h max. We have to apply the third equation, right? Third equation. So v square is equals to u square plus 2as. Clear? So v is 0, u is u square plus 2 minus g, and here we have displacement is, yeah, so displacement is h max, correct? So it is h max. Okay, sorry for handwriting, h max. Okay, so from here your h max will be nothing but u square by 2g is your maximum height. Clear student? You can learn this, no problem. Okay, now the next case, yeah, this is what we have found. Clear? Now the time taken to fall from a height h. Clear? So suppose if, again, next case, second case, suppose if this is our ground, okay, and here we have a ball, at a height h from the ground. Clear? At a height h from the ground, and you have dropped a ball. When this ball will reach to the ground, right? Time, you have to find time. You have to find, what do you have? You know acceleration is equals to minus g, right? Now displacement, if you drop a ball from here, so displacement is in downward direction, right? Correct. So your displacement is equals to minus h, right? Initial velocity is 0. Now which equation can we use? Yeah, correct, we can use second equation of motion. Okay, so s equals to ut plus half at square. So s is minus h, okay, u is 0, minus half gt square. So from here you will have your t, time, when the ball will hit the ground will be equals to 2h by g under root. Just think, this is your second formula, second case formula. All right, just check. You don't have to learn this as well, right? Now, okay, this is what we have done. If the ball thrown up, then maximum height you can find. Time taken to go up is equals to time taken to come down. You know this, right? Means suppose, now the second case, again third case. Okay, yeah, students, everyone here. Suppose this is your floor and you thrown a ball in the upward direction, right? So when this ball will reach to the maximum height, clear, this case we have found the maximum height. So now the time when this ball will reach to the maximum height. Okay, so again initial velocity you know u, final velocity 0, acceleration we know, first equation of motion. Okay, so for t what we'll do, first equation of motion, clear. So v equals to u plus at, right? v0 u minus g t, so t is equals to u by g. So yeah, here, so the time taken for ball to go up will be equals to the time taken for ball to come down, right? Total time of journey is 2t. Time of journey is equals to 2t. Just check, right? So this is the third case what we have discussed, right? Now, if the ball is dropped from height h, the particle hits the ground with a speed. This is what you have to do it by yourself, right? So these are the basic formula, but I don't prefer you to learn. I don't say you to learn these kind of things. Okay, you all have to do it instantaneously, right? Practice a lot that you don't have to learn these all. Okay, I hope this thing is very much clear, students. Thank you. So this lecture I will end here. In the next lecture we will go through the concept of non-uniformly accelerated motion. Means when the acceleration is not uniform, not constant, means acceleration may be a function of time, may be a function of speed, velocity or displacement, right? So in that case, how we will move, how we will solve the equations. Okay, then we'll see this in the next lecture, right? In the next lecture we will deal with the concept of non-uniformly accelerated motion. Okay, till now we have seen the uniformly accelerated motion kind of a concept. Okay, so that's all. Thank you, students. I hope you are doing well. If you have any problem, you can come to me, right? You can directly approach to our Telegram channel. The link of the Telegram channel is given in the description. Thank you, students. Stay motivated, stay blessed, stay focused and stay tuned. Thank you, students. Jai Shri Ram.